So hopefully you've watched the earlier video on how to actually solve simultaneous equations using substitution or using elimination. And we are going to look at some excellent examples of how these actually show up in word questions in the exams. So typically we're given some sentences and we need to come up with equations and solve something. In this case, to feed 3 cats and 5 dogs, Shannon uses 26 kgs of food for a month. And to feed 5 cats and 3 dogs, she uses 22 kgs of food for a month. Find out how many kgs a cat needs in a month. So it's a good idea to actually define your variables. C equals cats, and we'll call D equals dogs. Might make that a lowercase d. And let's write ourselves an equation. So the first sentence says to feed 3 cats, so that means 3 times C, 3 cats, and 5 dogs. That word and means plus 5 dogs. So 3 cats, 3 times C, and 5 dogs plus 5D equals 26. That's my first equation. And looking at the second sentence here, to feed 5 cats, so in this case 5 cats and 3 dogs, she uses 22 kgs of food. So now I've got 2 equations and 2 unknowns, and I can use substitution or elimination to solve this problem. I might demonstrate substitution because that can often be more helpful if problems are more challengingly worded. So I'm going to take equation 1 and equation 2, and I'm going to rearrange equation 1. So using equation 1, if I need to find out how many kgs a cat needs in a month, I might actually try to solve for the opposite letter. So let's try and solve for D, and you'll see why that works out for us. So if I rewrite this as 3C plus 5D equals 26, I am going to rearrange for D. So I have 5D is equal to 26 minus 3C. And now I need to divide by 5. So D is going to be equal to 26 minus 3C all over 5. So the whole thing is divided by 5. Now if that was a simpler fraction to reduce, I would, but in this case I'm going to leave it as it is. So now that I know that I can write D as 26 minus 3 all over 5, I'm going to actually substitute that in for D in equation 2. So now I'm going to get 5C plus 3, and using brackets, be sure to use brackets, I've got all of this other stuff for D. 26 minus 3C all over 5 is equal to 22. So I can leave that in blue. Is equal to 22. So again, I've just rearranged the first equation to get D equals something, and I've substituted that in to my second equation. So using substitution, replacing D with all of that. Now I can look at just trying to expand and simplify and solve for C. So 5C plus, a bit tricky here, but let's figure out what to do with this. Let's expand that 3 through on the top. So 3 times 26 is going to be 78 minus 9C. All of that is still over 5 is equal to 22. And now that I've got that done, I'm going to look at trying to maybe get rid of the fraction on the bottom. So good practice here with fractions. If I have a 5 on the bottom, one of my strategies is that I can actually times everything in this equation by 5. So 5 times 5 will become 25C, plus the 5 in this one is going to actually cancel with the 5 below because 5 divided by 5 is 1, so I keep the 78 minus 9C is equal to 110. Okay, so we're slowly making progress. Let's combine like terms here. 25 minus 9 in this case is going to be 16. And that plus 78, I can actually take that to the other side, 110 minus 78, and think about counting that out if you need to. What is it going to be? 110 minus 78, and we get 32. So 16c is now equal to 32. And hey, we're almost there. That 16 times c is equal to 32, so doing the opposite, we're going to have c is equal to 32 divided by 16, which is, in fact, equal to 2. So cats use 2 kgs a month. So at the start I said if I'm looking for cats, I might solve for the other letter. I might solve for dogs, which in this case I did. And the reason I've done that is because I know if I solve for d here, and I replace d in this equation, I'm left with the c's, which is what I'm looking for. So I've got cats at 2 kilograms. And just as an exercise, if I wanted to also find out what dogs was, I would plug it back in up here. So I would have d is equal to 26 minus 3 times 2, because c is now equal to 2, all divided by 5. So d is equal to 26 minus 6 divided by 5, and that simplifies to 20 over 5, which simplifies to 4 kgs. So in this case, the cats are 2 kgs and the dogs are 4 kgs. So that's one basic example of how to use the simultaneous equations with the word questions. Again, write out your 2 equations, make sure you define your variables, and use them to solve. So let's take a look at another example. Using simultaneous equations to solve equations again. One child ticket, one teen ticket costs the same amount as an adult ticket. So it seems kind of obvious, but we'll go ahead and label these. C for child, T for teen, and A for adult, just to make sure there's no confusion. So one child ticket plus one teen ticket is equal to the same as an adult ticket, and writing that out as a sentence. The next sentence, 2 child tickets, so that's 2c, plus 1t is equal to $30. And the third sentence here, 2 teen tickets, so 2t plus 1 adult ticket is equal to $50. Okay, how much does it cost for one adult, one teen, and one child altogether? So basically we're looking to find out what each of these costs. Now, this is slightly different than the previous example because here we're using 3 variables. We have a child, a teen, and an adult. So we're actually going to have to do a couple of substitutions to get this to work out for ourselves. But if we label the equations 1, 2, and 3, we can try to combine them and rearrange to find something. So part of our problem here is that in the first equation we have all 3 variables, so that's not very helpful to us. In the second equation we have only c and t, and in the third equation we have t and a. So we can't yet substitute directly with any of these, but we need to do an intermediary step. So my intuition tells me that we might want to look at comparing, not sure, possibly equations 1 and equations 3. So if we take a look up here, we have a is equal to c plus t already. So I could potentially replace this a with this one here, and then I would have, so using 1 and 3, replacing all of this for this guy here, I'm going to have 2t, what I started with, plus c plus t is equal to 50. So again, that's using the fact that I know a is equal to the child plus a teen, so I'm going to replace the a with a child plus a teen is equal to $50. And now I'm going to combine like terms. 2t plus t is going to be 3t plus c is equal to $50. And I might label this as equation 4. So So you'll notice now that equation 2 and equation 4 have the same variables in them. That's part of why I did that. So now I've got two equations with t's and c's. I can use substitution inside of that to try to solve it. And since it doesn't really matter which letter I look for first, I might just rearrange this one to make it c equals, just because that's easiest there, 50 minus 3t. So again, that's plus 3t, so I'm going to minus 3t. Now I'm going to take this equation, 50 minus 3t, which is equal to c, and I'm going to substitute that into the second equation. So if you want to be careful in labeling, using 4 and 2, so using equation 4 that I've rearranged and equation 2, I'm going to substitute that c with all of this green stuff here. And because it's more than one thing, you use your brackets. 2 bracket 50 minus 3t plus t equals, those look the same, plus t is equal to $30. And now we have just one variable that we can simplify to figure out. So here, expanding out my brackets, 2 times 50 is 100, and 2 times negative 3 is negative 6t plus t equals 30. So negative 6 plus 1 is going to be negative 5t is equal to 30 minus 100. So 30 minus 100, and that gets us 70. So negative 5t is equal to negative 70. And in our last step here, negative 5t, to get rid of that, that's negative 5t negative 5 times t. So we're going to divide. T is equal to negative 70 over negative 5. The negative divided by negative cancels out, and we end up getting 70 divided by 5, which is 14. So one teen ticket costs us $14. Okay, so let's work backwards and figure out what other information we can get. If I take that answer that I've just got, t is equal to 14, let's substitute it back in here. So now I'm going to get the equation c is equal to 50 minus 3 times, well, I did say t, but now that I know that t is 14, I can say times 14. So c is equal to 50 minus 50 minus 42. So c is equal to 8, which is information for us. And in our final step, we can take the fact that a teen is 14 and a child is 18 and put them both back up into equation 1. So we get 14 plus 8 equals the adult ticket, so $22 is equal to the adult ticket. And we can feel pretty smug and happy with ourselves. We've solved for the price of a child, teen, and adult ticket. But let's pay attention. If we don't answer the question, we don't get any credit for it. So they're asking how much does it cost for one adult, one teen, and one child all together. So we need to give them a total cost answer. So our total is going to be 14 plus 8 plus 22, which is $44. So I'd say my final answer here is $44, cost for one child, one teen, and one adult. So again, in this case, a bit tricky, but we've actually been given 3 variables, so I've had to do a few substitutions to make it work out. But what you're aiming for is to try to get at least 2 equations with just 2 unknowns, which is why that first substitution using equation 1 and 3 work out for me. So now I have just t and c in equation 4 and just t and c in equation 2. From there, I was able to substitute and find an answer for t, plug it back in, find an answer for c, and from there plug both of those back in to find the answer for a. So get out your workbooks and try a few practice problems on these.